Everyone, I'm welcoming you all once again to this channel. Today I'm going to make a nano cluster using our VESTA software, for which I have taken the gold CIA file here. So first I'm going to open that file. So here is our gold CIA file that we have opened using our VESTA software. Now in the first step I will go to export this file as a VAS format. So here I'm saving that file, and you can save it in any coordinates. So and now let's open that file which we have saved now. So here is our au.vas file. Okay, so now further modification we will do using this au.vas file. So for which I'm first going to this edit data and unit cell, and from here in the transform we will first create one supercell of size 444 along all the three directions. Click on OK. Yes, search atoms in the new unit cell and add them as a new site, apply, then OK. So here we have got our gold supercell of 444 size, and this is our middle layer. And here in this layer, this atom is the central atom. So you can see that this AU atom is having the coordinate point 0.5, point 0.5, point 0.5 along all the three directions. So this is the central to all to the entire supercell. Now to create the nano cluster, we have to choose one atom which will be central to the supercell, and from there we will try to find out the distances within a certain range. So that's why I have chosen this atom. Now we will go to this edit data. In the structural parameter, I will locate that AU dot that atom, this 43 number atom, and I will change it to some other atom so that it will be very easier for us to locate. So here I am changing this AU to rubidium so that we can see that this is our central atom. So now you can see in the place of that AU atom, we have now this rubidium atom, which is the pink color atom here. Okay, now what we will do next? Now here in the bonds, we will try to find some bonds from this rubidium to the other atoms. Now here I am going to create new bond, and here the first atom will be RB, and from RB to other atom we are going to search atoms bonded to A1, and the maximum length here I am taking, you can take 5 or 7. So it depends, like you how long or how what will be the radius of your nano cluster. In that way you can take your size. Suppose we can take maximum length as 7, and here all the different distances are mentioned in the angstrom unit. So the maximum length is 7. I'm taking 7 angstrom, so click on apply, and okay, now you can see that we have seen a lot of bonds that are formed with this rubidium atom along all the side. Now in the next step we will try to delete the extra atoms which are not bonded to the rubidium. So I am going to select this option, and then we will select those atoms which are non-bonded to it and simply press delete. Similar way we will do this side. And we have to be little careful about all the non-bonded atoms, and we have to delete all of them. And let me rotate this supercell little bit. Yes, you can see that so many more non-bonded atoms are also present, so let's remove them as well. And let's rotate it further to check. Yes, some other atoms are also present, and I'm removing them. And here also. And so along all the side we need to check whether we are missing any atoms or not. Yeah, now we have deleted all those non-bonded atoms, and these are the atoms which are only bonded to the rubidium are present now. Now in our next step what we will do, we will go and simply save this file into one xyz file. So here I'm choosing the file format as xyz, and it will save that this to. And here also it's showing that whether you want to see the save the hidden atoms to no. And I'm again going to open that structure which we have saved now, that is this au.xyz. Now you can see this is our xyz file which we have saved after creating this nano cluster. Now in the next step what we will do, we will try to remove this rubidium atom. This was one extra atom that we have added in the place of the AU. So here again I'm going to the same. So where is that RB? We need to find out. Okay, let's go and select this atom. So this atomic number is 10. Atom number is 10. Here let's go to this edit data structural parameter, and at the 10th position again I'm going to change this to AU. This also AU. Apply. Okay. So here we have got now our nano cluster of the gold. We have got our gold nano cluster, and in the next step, if you want to see it from the different formats like space filling, polyhedra, wireframe and all, so this you can also choose. But here we have seen that in while clicking this polyhedra we are unable to see anything. So for that what we need to do, we need to again add some bonds between this AU and AU atom. So here first let's click on these atoms, that how much bonds they are forming. So from here to here the bond distance is 2.88376. From here to here the bond distance is almost same. And even if we will choose in between the layer to see that how much is the distance, so the distance is also nearly 2.88376. So almost in the entire nano cluster they have maintained this much bond distance. So in our next step we will try to provide that much bond distance so that they can form a bond among themselves. So here I am changing this number to suppose 2.89, so that they can form the bond in between this range. And click on apply, and here also click on apply. So now you can see the, like all the bonds that can be formed within that range we can see from this structure. And here if you will go to space filling you will see this kind of thing. If you will go to polyhedra, now you can find your nanocluster in the polyhedra format. So this way if you are interested to create any nanocluster of any kind of structure you can try to make that. And at the end you don't forget to save it again, because we have modified the data. And you can also save it to the same xyz file and simply replace the same. And I'm going to again open that structure to show. Yes, now you see that we have got our correct nano cluster. And yeah, that's all from for today. And thank you all, and bye bye.